Workshop, and welcome to another Thunder Laser video. So today's video I'm going to show you a couple of features of this Thunder Laser Nova 35 and a little bit of routine servicing. Okay, before we start, I've had a lot of people ask me, what are the fans running? Well, down in the side cabinet down there, there's two fans that keep the air circulating in the electrical cabinet. So it keeps everything cool. And in Australia, that is a very, very good feature. And I would say a lot of other parts of the world as well. Okay, so what I'm going to do is take this front panel off. Very easily done. Very heavy too, heavy gauge steel. In fact, the whole machine is very heavy gauge steel. And the next thing I'm going to do is drop this front panel, because the last video that I made, I did a lot of complex cutting of very, very small parts. I made a lamp, and indeed the job before that I made this little box joint tray, which is very handy. Okay, so of course all the little bits of squares off this and all the little parts from making that decorative lamp are all pretty well, 50% of them you can say has dropped through into the bottom of the machine. And of course with a Thunder Laser that's not a problem. I'll show you why. Okay, let's get down here on my knees. More comfortable that way. So, more locks. And we drop this down. Now here's all the parts that fell through, and I'll tell you now that this is the best equipped laser that I've actually ever seen for containing the parts that fall through. You know, it totally, this belt here, this is for the Z-axis, it totally protects all of that, and in fact the tray at the bottom is actually larger than the honeycomb bed, so you know it captures 99.9% of anything that will fall through, and it's so easy to clean. I mean, there's magnets on this tray at the back, so you just give it a bit of a, and it comes straight out. And you can hoover it or sweep it or whatever you want. Or indeed, they've got grab handles here. You can take the whole tray out, and if you wanted to power wash it off, put it back in. So I'm just going to clean this little mess up, and I'll get back to you. It's as easy as that. I'm just going to drop the table down because I'm going to show you another important little feature. Okay, a couple of things here. First of all, big heavy gantry front and back to support the honeycomb bed, and also, if I can lift this up, that's heavy actually, also the knives as well. But this is what I want to show you. Attached to the base of the honeycomb, here, and at the back as well, there are dowels that line up with holes on, dowel holes on the gantry. Like that. So this means that you can accurately locate a part on your honeycomb bed or even locate a jig on the honeycomb bed, and you know that it's going to be in exactly the same spot every time, because the honeycomb bed is locked in position. So you can actually attach something to the honeycomb bed every time and know it's in exactly the same place. Okay, the next thing we're going to look at is just general servicing, cleaning of the mirrors. And when you purchase your Thunder laser, it will come with these special lens and mirror cleaners. Okay, it's special material so it doesn't scratch. Certainly the lenses. Plus lens cleaner, lens and mirror cleaner. Incidentally, the mirrors on these lasers, they're not glass. They're actually polished metal. Okay. So we'll move the gantry forward and over and we'll have a look at cleaning the mirrors. Okay, this lens cleaner, don't spray in on the mirror itself, just spray a little bit on your Q-tip or whatever you want to call it, and just pop it inside. If I can do this without getting my head in the way, just spread it around like this. There's nothing really coming off on there. You wouldn't expect it because I haven't. So I'm just turning over now to the dry side. Getting all the nooks and crannies everywhere you can, and that's looking pretty good. You'll actually be able to see a little better on mirror number 2. This is mirror number 3. Okay, use a new Q-tip. Just wet one side of it. See if I can do this without keeping my head out the way. Yeah, not much coming off that one either. We'll just get another one, dry it off nicely. I'm going to make sure the entire mirror is clean and dry, because the beam, you see the red dot laser there, the beam is not that big. The beam on any sort of 100-watt laser is approximately 12 millimeters in diameter. So, you know, it can use quite a bit of the mirror there. So you need to clean the entire mirror, and that's now beautiful. So now we'll go to mirror number 1. Okay, there are two. There's one, shall we say, one-way mirror here, which is the red dot laser. This is the little diode laser here that shines into this little window here, and it's important to clean this one like this, both sides. If I can get in here. Changed Q-tip. Nice dry one now. And clean that right off. Let's get another one a minute, and then we'll clean this one. The new one, dry one. It's a good idea to probably use a fresh, clean one for each mirror. And don't put your fingers on these, because the acid on your fingers, you know, it is possible can interact with the mirrors or the lenses. That's good. Not much on them at all, actually. I'll just show you something on the end of the laser here. Okay, of course, mirror number 1 is around here at the back with the laser. And something else you'll notice too. Now, inside there, that is a quartz halogen 75 watt globe in it's a lead lamp, actually, from the motor trade. So that provides heat in this compartment during the winter in Tasmania. Of course, last night where I particularly live, it was 2 degrees below zero and a little bit of wind. So it's quite possible that you could get, you know, you can destroy your laser tube if it freezes. So, and although there is a chemical additive that you can purchase to go in the water system, I don't like using it at all. I don't use it. It's my personal preference, because if you discolor that, if you put anything in there in the water system other than distilled water, it allows, shall we say, electrons, or photons for that matter, to be interactive with the water system, and it can diminish the power output of your laser. Shall we say, this laser operates at, for example, 25 to 30,000 volts, and when it is operating, around the outside of this tube, inside this compartment, is energized with electrical particles. I have measured this in the past, and it can be quite a significant amount on the outside of the tube. Now that is required by the laser. It's part of the laser action inside, that it has an electrical component on the outside. So if you interact with that or disturb that, you can diminish the laser output. And that's another good reason to keep this shut when you are operating your laser, because you can get a belt off the outside of the tube. Okay, so that's a number of things there. Let's get to the mirror number 1. Now, you heard me just saying that the actual diameter of the laser beam is about 12 or 13 millimeter. Well, there you go. That's the orifice coming out of the end of the laser, and the laser beam is the entire diameter of that outlet. Now that is telling me that's what, 10, 11, 12, 12 and a half? It's actually half an inch. So that's the size of the laser that comes out of the end of the laser tube, and it is actually called a Gaussian shape laser beam. Okay, some of you may have just picked up I used a magical word, Gaussian shape. Well, this is a Gaussian shape. It's a power density map. In other words, the laser beam, as it comes out of the end of the laser tube, is spherical, it's round. Okay, the beam is round. But its power density, alright, is relatively low on the outside of the beam, and as you go towards the middle of the beam, it gets more intense. And this is, whoops, that's better, stay there. And this is a representation of the power density of your laser beam. Now, of course, this beam being half an inch or 12.75 millimeters, it is 12.75 millimeters that gets bounced around inside your thunder laser until it meets the lens in the nozzle which directs it onto your work. Now that lens takes this beam of half an inch and focuses it down to a diameter of approximately, with a 2-inch lens, which is the standard lens that comes with your thunder laser, approximately 0.19 of a millimeter. That's the outside diameter of your beam. Okay? So when you're using a laser beam, and this is very, very important, we're going into the science and the physics of a laser now, and how it does what it does. So you have an overall size of beam now after it's been focused onto your material of 0.19 of a millimeter, which is very small. But that is out here, because when you focus the beam into that very small area, it is still a Gaussian shape. The lens doesn't change the power density of the shape of the beam. All it does, it concentrates it smaller. So, out here is 0.19 of a millimeter, but where all the energy of the beam is, which is in this area here, okay, this is less than 0.1. You get my meaning? You understand now? So this is spherical, it's round. Alright, so this is cone shape, or Gaussian shape. And when it goes through the lens onto your work, it's still this shape, but it's very, very much smaller. So this area here, from the outside to outside here, that is going to be 0.19 of a millimeter. But where all the work is done, which is basically this lower part here of the beam, is very much smaller. Less than half of the overall size of the beam. So where I'm going with this is to try and explain to you how I'm going to do the next series of videos, and I want you to have some understanding of, well, if the beam is 0.19 of a millimeter, how are you going to get a dot size smaller than 0.1 of a millimeter? It's all to do with speed and time. Because the faster the beam moves across the surface of the material, okay, the less time the beam has to do damage or mark the material. Okay, so if you're running at 100 millimeters per second, you're going to use best part of all of the beam. Okay, so you're going to get a spot size of 0.19. But if you're moving at 300 millimeters per second, it's only this part of the beam down here where the high energy level is, it gets a chance to actually damage the material. So down here the beam is 0.09 or smaller. So that is how you get a smaller damage area or dot size. And we're going to be using that phenomena in the next series of videos, doing 3D carving and photographic imagery onto material. So, there's a little bit of information about your thunder laser of, well, cleaning up procedure and the well-made unit that it is, and the thought by the engineers, of being able to clean it, slide out drawer. It's really amazing. It's an amazing piece of kit, and I love it. And I hope I've explained about the Gaussian shape of a laser and how you are able to get a very much smaller dot size than what the actual beam is. And we're going to learn more about that in the upcoming videos, where we're going to do some 3D carving and engraving, and also photographic reproductions on different pieces of material. So I hope you've enjoyed the video today. It's been quite a short one, and but it's been pretty well packed with some information. And well, please like and subscribe, and you may consider becoming a patron to my channel. Patron information is below this video in the video description area. So thank you very much for joining me, and Thunder Laser, and I'll see you on the next video. So it's bye for now.